Okay, we're going to be looking at Diewalls here today. First time looking at these. They have been brought up a couple times in the past, but we're going to be taking a look at the construction of Diewalls as well as the vocabulary of Diewalls. Similar to what we did before, we were talking about cabinets, there is a fair amount of terminology that goes hand in hand with Diewalls. So we're going to kind of jump right in and take a look at what we've got. Here I've got a couple of actual documents that explain the different parts of a die wall, in which we're going to be kind of discussing these first before we get into more of the rules and sort of, I guess, if you want to call them regulations, like on-site standards on how to build these. Um, the things that I want to look at with you first is when you're dealing with a die wall, you have horizontal components such as this here, that is your top plate. You got a base plate and what's also called a locator plate below that. So there's some horizontal components there. And in between, you'll notice there are vertical components that are spaced every so often. Those vertical components are called ribs or also called studs, depending on the person you ask, but it's the same exact thing. Generally at onsite, we call these ribs, but they're the same thing. So think about it like you're building a wall in a house. You're going to have studs or ribs, and they're going to be spaced a set distance apart. Um, you have your top plate, again, which is up here, bottom plate, of course, and then your locator plate. Now, there are some other components that we do need to look at as well. So inside of the ribs of your die wall, you'll see that there are holes right there. Generally, every die wall is pretty much going to have these. Sometimes they may be too thin to have these, but in general, you will pretty much always see a hole through your rib or your stud. Those are used by electricians and plumbers generally. And what they're called is a wire chase or a plumbing chase. Um, we will route these holes out in our shop and we'll assemble the walls and they'll go out to the field with these holes in them. And then the electricians will come in later and they'll take their wiring and they'll run it through these holes in the die wall as they need to be able to get to outlets or whatever they need inside of that wall. So that is a wire chase or a plumbing chase. Can be used for either one. Those are used inside of die walls. Typically, there are rules for the size of those and how they interact with the ribs. So we'll talk about that later. Some other things that you're going to see, more horizontal components on this die wall specifically. You have two boards that run here and here. Those boards are called nailers, and they are literally used to nail panels to the die wall. So if you have a wall that you have panels on that are okay with being fixed, they don't have to be removable by any means. You can use nailers on that die wall to make that work. So again, just kind of illustrating that. If you're looking at the side, like the section view of that die wall, like if I was cutting through here and looking down like this, if I'm cutting through the die wall like that, this is what I'm seeing here. So I have those ribs right here. You got the bottom plate, the top plate, and the locator plate at the floor. All right. If you notice a couple things here, the top plate is the same exact width as the ribs or the studs. Same thing with the bottom plate. It is the same exact width as the ribs or the studs. The locator plate, if you need a locator plate, will be the entire footprint of the die wall, including any nailers or cleats or anything attached to the side of those ribs. So you'll see that it does stick out. That's intentional. It's supposed to stick out. It's intending to be the exact width of anything attached here, aside from the panels. Like if you have panels, you don't include those. but you're going to have it the same width of anything attached to that Diewall like this. Now, if you wanted to put panels on this Diewall, because you have the nailers on this side, you could throw a panel like this on the side of that Diewall, and it would look something like this. From the inside of that Diewall, we would use fasteners like screws or nails here, and we would attach that in through the back of these nailers, just like this. So those are held in by screws or nails from the inside of the Diewall to the back of that panel. Now there's other attachment methods that you're going to see on Diewalls too, and we'll skim through those real quick. So you're going to see here in this example, we're using standard panel cleats. Remember when we talked about panels in the past when we've been working on those? Panels do still require a 3/4 inch liftoff space. So if you were to use panel cleats for this Diewall and you were going to try to draw in a panel like we just did earlier, if you have a countertop or anything above these cleats in this panel, you do need to make sure that you are including a 3/4 inch gap between the top of that Diewall and the panel itself. Typically what we'd do is we would put in a full depth reveal block like this at the top of that panel there, and then that would form that 3/4 inch full depth reveal right here. All right, so that's really important. Anytime you have a panel with cleats on it, whether it's on a wall or on a Diewall that we're building, you do have to make sure you have enough lift-off space for that panel to be installed. So, yep, so that would be a standard Diewall with cleats on the side to attach that panel. Otherwise, nothing else has changed here. We have the same exact Diewall from this page to the last page in this document. So there are other items that you can look at too. So for example, another attachment method for a panel on a Diewall is to use something called an integrated cleat. Integrated cleats are built into the ribs of that Diewall. Now, you do still need to have 3/4 of liftoff space at the top. But if you notice, there really isn't room to put a full depth reveal up here. So what we usually what we'll do is we will, sorry, I feel like I'm gonna sneeze. Oh, okay. Usually what we'll do is we will either paint or prime the top plate black up here. To hide the fact that there is plywood up here. So we'll paint that black or prime that black. That'll hide the fact that there is a gap there at the top of our Diewall. But again, anytime you use cleats, regardless of them being attached to the ribs or being built into the ribs, you still have to have a 3/4 inch lift-off space. So that's really important right there. Okay, so moving on. So if you have a wall with integrated cleats, that's how you would handle that. This Diewall here is designed in a way that you can use both integrated cleats as well as nailers. So let's say you had a like a half wall in a building, and you were supposed to clad that half wall with panels on both sides. So ways you can handle that is if you wanted to, you could do your panel on one side using the integrated cleat method like this. We would still prime the top plate black. That way it's less noticeable. And then this panel here, because it's on nailers, can actually go all the way up to the top, just like this. So it can be in line with the top plate because it's being attached with nailers or screws and nails in the back. Anytime you have panels on two sides of a Diewall is really, really important. Make sure you note this here. anytime you have panels on two sides of a die wall, you have to have one side at least removable. Both sides could be removable. It wouldn't be really the end of the world, but it's also not necessary either. The reason that one side has to be removable is you wouldn't be able to do nailers on this side and this side, because if you think about it, you wouldn't really be able to get a drill or a hammer in here to be able to attach the back of this panel to those nailers. And you could do it on one side, but you couldn't do it on both sides. So anytime you have panels on two sides of a die wall, one side always has to be removable, just like this. All right, let's keep on moving. So we're also going to run into scenarios here like this, where you're building a die wall with a toe kick built into it. So typically you'll see these on desks, sometimes islands, mostly furniture pieces like desks though. There will be times where you're going to have you're going to have a desk with framing like this, and you're going to need to clad that framing with panels like this. So honestly, that's pretty standard. You'll see that a lot as you get into the desk, maybe bars, maybe islands. You'll see that a lot more. Now, if again this die wall was standing alone by itself, you would want one side to have a removable panel. If you only needed panels on one side, it is perfectly acceptable to put nailers on that one side and attach it from the inside out, because you have full access to the inside of this die wall right here. Now, just because a die wall has a toe kick doesn't make it any more scary than a standard die wall, but you will see as you look at those die walls with those toe kicks, there is still some standard items that you're going to see. So you'll still have your locator plate at the floor. You're still going to have your bottom plate right there. But you'll notice there's an addition of a third plate that sits right there. That's your toe ledge, or an extension of your bottom plate. I'll sometimes refer to it as the bottom plate, but really toe ledge is probably the proper term for that. So what that really is it's another, if you think about it like a bottom plate, that's kind of what it is. So really your rib zigzags to make that toe kick, and then you need part of your bottom plate here, part of your bottom plate there, or your toe ledge there. And that helps formulate the zigzag that you're seeing there. The top of this does not change. We still have that top plate there, just like this. That has not changed at all. And so that is very familiar to us here at this point. Let's also talk about some of the construction of how this comes together here. So as you're looking at these die walls, you're going to see some things that kind of jump out. Something that I'm kind of referring to here is that, and I'm trying to find a good view of it so you can see it better. Yeah, really, not a lot of these do a good job of showing it too well. You kind of see it here, but I don't want this to get too confusing, but we'll look at this one. So you'll see you got your ribs here. Your ribs are going to extend from the top plate to the bottom plate, just like this, like what we're showing here. But there are small notes here that do say top and bottom plates are dadoed 1/4 inch to lock into the studs. So what that means is that when you build your die wall, your top plate and your bottom plate have grooves or dados that are built into them. So that way, when the shop goes to assemble the die wall framing, all of those stud locations are predetermined. And it also comes together kind of like a big jigsaw puzzle. So if you want to see a better example of that, you can kind of look over here on the axonometric view on the right, and you can see right there, this rib is dadoed in 1/4 inch into that bottom plate. You can see that here too. So there's your bottom plate. It steps down, and then your rib kind of just sits in that little nest or that dado that sits right there. The same thing goes for the top plate. The top plate, you can also see there's a 1/4 inch pocket for the rib to sit. Same thing here, 1/4 inch pocket for that rib to sit, and that just carries on all the way through. I also have a small treat for you too. A while ago we had a Diewall that was out in our shop. Not a very big one, but a very good example of how this stuff comes together. So as you're looking at this particular Diewall, this one did have removable panels on both sides. So you can see where those integrated cleats would have been right here in these pockets. You can see the wire chase that goes all the way through each rib, just like this. And if you look close enough, you can actually see that dado. It's kind of hard to see in that particular picture, but let me see if I got a better view of it. Okay, so you can see it a little bit here. It's kind of tough to see, but if you look, you can kind of see that pattern of where that rib goes, sitting about right there. And so if I'm looking at it, you can see that it goes up into the top plate 1/4 inch, and then there's a little pocket for it to rest inside of. That is a little bit noticeable over here too. You can kind of see that a little bit. There's your pocket right there, right there. That's your 1/4 inch dado right there. So that dado exists at the floor in this Diewall too. It's kind of hard to see in this picture, so let me see if I got a better one. Side view of that Diewall does a very good job of illustrating that. So you can see that 1/4 inch dado pocket right there, just like that. Okay, so again, that is an all the time sort of deal. Anytime you have a Diewall, you'll have your base plate, bottom plate, and top plate, and then these will be 1/4 inch routed into those two plates, which lock in the ribs. Also helps locate those for the shop, so they don't have to locate all of those by hand. Those routes are done on the CNC. There's a bonus little fact there in case you were wondering. So if you're out in the Illinois branch and you want to go see some of that in real life, go on out to the shop and you'll probably see some top plates and bottom plates lying around over by the Rover, the CNC out there. You can go check that out, or if you go over to the assembly areas, assemblies 1, 2, or Kevin's corner of the shop, you'll be able to see these routes and these plates out there in the shop too. So might be a good idea to go take a field trip out there and take a look at that, because those are going to be great examples of real life on how to build these. Now, these pictures do a pretty good job of showing the construction of these, but at the same time, it's always good to have a real life example of that too. All right, so again, you can see those are your integrated cleat spots where those cleats would end up getting attached at some point later down the road, up there and down here. You got your wire chase or your plumbing chase, which are these holes that go through the middle of the ribs. You got your top plate up here. This particular Diewall actually has a plate on top of that top plate, but there's the top plate. And this one has a bottom plate right, well, I think you get the idea, right about there. So bottom plate sits at the bottom, top plate sits at the top, and then sometimes there will be a locator plate that is attached down here as well at the floor. All right, so that's kind of a real life example of a Diewall. We're going to go back to our example sketches over here so we can kind of see what we're dealing with. So we did talk about the dado for the ribs, how that's dadoed into the top and the bottom plate. We talked about the wire chase briefly, but we need to come back to that a little bit more. We've also tackled attaching panels to a Diewall and how that can be done. So let's take a step back to those wire chase and plumbing chase notes that I was going to get back to here. So the plumbing chase or the wire chase, those are typically going to be circular holes that are routed into the side of the rib, and they go all the way through that rib from side to side. There are rules about these. You do not want to eat too much into that rib. So anytime you have a wire chase or a plumbing chase, it is a very good idea to make sure that you have this 1 inch minimum dimension to the outside of that rib like this. Anything smaller than that, and it starts to eat into the structural um, component of the drywall, and you don't want to eat into the rib too much, because if you do, it could make the drywall weak, and eventually over time it could break down. So really good idea. Always try to make sure that your wire chase is no more than 1 inch from the inside of the hole to the outside of that rib like this. All right. Now typically we put 3 of them in each rib. It's going to depend on what you're drawing, how tall it is, and the need for the plumber or the electrician. Most times 3 holes is going to be plenty, enough for them to be able to do what they need to do. They may have special requests during the red line process where they may request a larger wire chase or a different type of wire chase that may be a larger hole, a different route, different routing location. That can all vary, but generally what you're seeing here is our standard of what we would normally do. So that really doesn't change much. All right. So let's talk about anything else here. Oh, yes, rib spacing. Rib spacing is going to also be really important. So anytime you have a straight drywall like this, your ribs are going to be no more than 16 inches on center, meaning that if you were to pull a dimension from the center of one rib to the center of the next, you are going to be at 16 inches or less. You don't want to go too small. Like you don't want to go down to like 8 or 9 inches here because it's a straight drywall. 16 inches is plenty of space. But it doesn't also affect the structurability of the wall as long as you're going no more than 16 on center. These ribs are also going to be made out of 3/4 inch plywood, as you can see here. Same thing with the top plate, the bottom plate, and the locator plate. All of that will be constructed using 3/4 inch plywood as well. So if you go back to that example I had there, you can kind of see that right here. So again, just recapping, straight runs of drywalls, ribs are no more than 16 on center, but they can be less than that, but just no more than 16 on center. All right, so we've covered spacing of the ribs, we've covered the wire chase requirements, we've covered the vocabulary of these drywalls, top plate, bottom plate, locator plate, and ribs. And we've also discussed attachment methods for panels on drywalls here too. So in general, that's pretty much the basic rundown of straight drywalls. Now, you're also going to run into curved drywalls in your time here. It won't be as often, but you will see these occasionally. So curved drywalls are a little different. Again, straight runs of drywalls, you can't do more than 16 on center for the ribs. Curved drywalls, let's see, what is the current standard? Oh, okay, so there are some stipulations to what we're going to do here for these. So if you have a curved drywall, these are the notes I want to look at real quick. So you can talk to a lister or a shop member to see what the construction method would be for a curved drywall here. So there are 3 rules about this. So the first one, if curved drywalls have preformed panels being attached to the ribs are spaced 10 inches apart at max. Okay, so again, what that means is that the shop is going to build a form, like a vacuum form. They're going to apply glue to the panel that's being formed, and they're going to start that vacuum form process. That process takes a while. I think it takes a couple of days. Maybe I'm wrong about that. I think it takes a couple of days for that to hold. Once the glue is dried and the form is complete, what they'll do is they'll take that panel off of that form, release the vacuum, and then they will attach that panel to your drywall. Now, that's that first step there. So if you have panels like that that are being formed or vacuum formed in the shop, then you can have rib spaced at 10 inches apart max. Now, there's other rules though too, because you can do these a different way. So if your curved drywall is being used to form the panels and you're not using a separate vacuum form, what they usually do is they use this material that's called 3/8 bending stock, and it's 3/8 thick, and they layer it up, usually a couple layers to build it up to 3/4 of an inch thick, and um, they'll nail these bending stock panels to the ribs on the drywall. Now, if you're using bending stock and you're using drywall to hold the bending stock to it like this, then your ribs have to be a maximum of 6 inches apart, which does seem pretty narrow. But the reason for it is if you have anything larger than that, what you're going to start to see is what's called segmenting. So segmenting, what it looks like in the field is, let's say you've got bending stock um, on these here. What you're going to start to see is you're going to start to see this happening here. And so anytime you're using bending stock with with ribs, you want to make sure that they are no more than 6 inches apart, because you don't want to see the ribs sticking through the drywall like this. The closer those ribs are together, the less noticeable that will be. Now, it probably will never be 100% not visible, but the closer these ribs are, the better it's going to be for that. So that's, again, if you're using 3/8 bending stock on these ribs, and you want to make sure that they are no more than 6 inches on center or 6 inches apart from one another. All right. Then the last rule is this is different actually. The assemblers will adjust the ribs to match the radius of the top and bottom plate. So that really doesn't pertain to this. Actually, I kind of misspoke. Really, these two rules are the more important ones. We're going to be paying close attention to that as we're drafting a curved wall with panels applied to it. We want to make sure we understand if the panels are going to be vacuum formed or if they're going to be constructed using 3/8 bending stock to build these panels. Once you know the construction method of how that's being built, then you know how far apart your ribs need to be spaced in your wall. So most times you're going to use 3/8 bending stock, but there are times where you will want to use the other method too. And that's going to be determined mostly by a lister or by a shop member when they get to the print. So you can get ahead of the game by talking to them first and just checking to see what they think is more appropriate for the drawing that you're working on. And so like here, this drawing here, you can see a wall that has those two layers of 3/8 bending stock applied to it, which shows the two layers right there, and they're being attached usually via nails to those ribs like this through the front. They usually skin the front of it with a laminate or a veneer, and then you don't see those nails. So there you go. All right, let's look at something else though. So this here, it's the exact same thing. It's just showing a curved drywall with a toe kick at the front of it. So really that's not much different there. So, yep, there we go. And same deal with this, just a smaller version of that. Don't really need to look at that specifically. Okay, I knew that was going to happen anyway, so keep talking. All right. So, all right, that's pretty much it though. So really you want to pay attention mostly to these two here for your rib spacing on your drywalls. It's going to be really important for future drawings. So as we go through that, just, kind of keep that in mind. So the first drawing we're going to look at together when we get into 3D modeling a drywall, we're going to be looking at an elliptical table. So it will actually be dealing with curved panels. And I think what I'm going to do is treat it as if I'm using 3/8 bending stock, like 2 layers of that on the panel. And we'll work through that together and actually make a three-dimensional model off of what we just learned about 3D modeling, plus the addition of what we just learned about die walls here. So if you ever need to come back to this, feel free to. Um, you know, all this is really, really important information. It doesn't change much, like very often. So if you feel the need to come back to this or you want some additional help, please reach out. Otherwise, these will be here via YouTube or the file folder. And I can also get you access to these drawings here if you'd like. Just reach out and let me know if these would be helpful to you. Um, these, again, are just supplemental drawings to kind of get you an idea of how die walls are supposed to look and work. So, um, all right, I think that's about it for die walls, at least for right now, until we really get into drawing them. That's really all you're really going to kind of get into. So next video here, we're going to talk about the table drawing that I have reserved for training. So we're going to look at that next. And then we'll probably do maybe 2 or 3 of those tables and islands. And then we will move on from there to most likely bars or desks. We'll figure that out later. But for right now, this is kind of where we're going to leave it for today. We'll move on to our drawing next for that island, or sorry, table.